Welcome. Today we're going to be looking at the rate of change calculation found on the front cover of the reference table. The rate of change states, rate of change can be determined by dividing change in value over time. Remember, the rate of change can also be abbreviated ROC, R-O-C, for rate of change. Change field value over T, or you could do ROC equals delta, which stands for change, field value over T for time. So the types of questions you might be looking at will determine what your units will be. Remember, the rate of change formula will always have an answer, usually rounded to the nearest tenth, and the units will be determined based on the specific question you're looking at. An example of a type of rate of change calculation would be something like this. The graph below shows temperature readings for a day in April. The average rate of temperature change, keyword change, in Fahrenheit degrees per hour, they're telling you the units, between 6 a.m. and noon was. I need to go and pluck out the data that we will plug into the formula based on this chart that they've given me. So from 6 a.m. to noon, let's see, 6 a.m. is here. The temperature value was very clearly 30 degrees at that time. At noon, the temperature value increased to a value of, I don't know, I'd say maybe about 48 degrees. So we come back to our formula. ROC equals delta field value over time, or change in value over time. ROC equals, let's see, we said that this was approximately 48 degrees and this was 30 degrees. So 48 degrees Fahrenheit minus 30 degrees Fahrenheit divided by the change in time. There is 6 hours of time between 6 a.m. and noon. So we will be dividing by 6 hours. ROC equals 48 minus 30 is 18 degrees Fahrenheit divided by the 6 hours gives me a rate of change of 3.0 degrees Fahrenheit per hour. So a very easy application of the rate of change formula. Another type of question that you might need to use this formula for is just a straight word problem. For example, a glacier advanced down a hill from an elevation of 2,010 meters to 1,780 meters, or 1,780 meters, in a total of 5 years. What is the glacier's rate of movement? Let's break out the rate of change formula. ROC equals change in field value over time. The numbers here are 2,010 meters minus, you'll notice we always put the larger value up front, 1,780 meters over the time, which they very clearly identified as 5 years. Using your calculator, 2,010 minus 1,780 equals 230 meters on top divided by 5 years on the bottom gives us a rate of 46.0 meters per year for the rate of change at which the ice moved downhill. A final example or sample question might read something like this. As Hurricane Felix neared the United States coast, air pressure dropped from 996 millibars to 980 millibars in 8 hours. Let's pull out the important information. Definitely going to have a change in value between these two values, and the time very clearly stated as 8 hours. So, rate of change equals delta field value, change in field value over time. Plugging in my numbers, I've got 996 millibars, always abbreviated MB, minus 980 millibars, divided by my time difference, which is 8 hours. ROC equals, plugging my numbers in, 996 minus 980 equals 16 millibars, divided by 8 hours gives me a rate of change of 2 millibars per hour. Again, if asked to round that to the nearest tenth, the answer would actually be 2.0 millibars per hour. So, this is a review of the rate of change formula found on the front cover of the reference table. I hope that you have found this helpful. Thank you very much.